GCC, we're continuing on with Chapter 13, Stoichiometry. We're going to practice some more mole ratios real quick. So we've got a balanced reaction for you. We've got sulfur dioxide gas plus oxygen gas makes sulfur trioxide gas. I want you to pause and balance that for me real quick, please. Okay, I hope you balanced that reaction and got 2, 1, 2 as your coefficients, because we have to have a balanced reaction in order to do stoichiometry. All right, let's look at our first question. How many moles of sulfur trioxide will form if 0.165 moles of oxygen gas react? Now, how do I know this is a stoichiometry problem? Well, we should have two chemicals in a balanced reaction. Let's see. How many moles of SO3, there's a chemical, will form if 0.165 moles of oxygen gas, there's a chemical, react. So two chemicals, and we do have a balanced equation up there. All right, perfect. So it's going to be stoichiometry. Start with what we know. Start with what's given. We're given 0.165 moles of oxygen gas. Okay, so we're going to start with that. So then we have our mole ratio, a mole on top and a mole on bottom. That's a mole ratio, right? Mole over mole. Which mole has to be on the bottom to cancel out with what we started with? Yes, moles of oxygen has to be on the bottom. How many moles of oxygen are in the balanced reaction? Just one. So 1 mole of oxygen is on top. What are we trying to find? Yeah, SO3. So moles of SO3 are on the bottom. How many moles of SO3 are in that balanced reaction? Yeah, 2. So your setup should look like this. 0.165 moles of oxygen times the mole ratio of 2 moles SO3 over 1 mole oxygen. Moles of oxygen cancels out top to bottom. And we do the math and we get 0.33 moles of SO3. 0.33 is what the calculator shows. Why did I add a 0? It's those pesky sig figs. Yeah, we started with 0.165, 3 sig figs. So we have to end with 0.330, 3 sig figs. All right, let's look at the second question. How many moles of SO2 are needed to make 0.042 moles of sulfur trioxide? Do we have two chemicals in a balanced reaction? How many moles of SO2 are needed to make 0.042 moles of sulfur trioxide? Yes, we have two chemicals in a balanced reaction. That means we're going to have a mole ratio. I want you to pause and work this one on your own. Pause. All right, here is the answer. I hope you were able to get this. 0.042 moles of SO3 is what we start with because that's what was given. And the mole ratio is 2 moles of SO2 on top over 2 moles of SO3 on bottom. Moles of SO3 cancel out, and we're left with 0.042 moles of SO2. 2 sig figs. Good job. All right, now let's think about these questions. We're asking about moles, and we're starting with moles, and we have a mole ratio. When you're in the lab, when you go up to the balance, is that in moles? No, it's weighing. When we weigh something, what's the unit in the metric system? Yeah, it's grams. So grams is what we weigh out in the lab. So we can't really start with moles because we go and we take a chemical on the balance and we weigh it out. So we're going to start with grams. Well, if we're starting with grams, but we need to do a mole ratio, how's that going to work? We need to go from grams to moles first. Then once we're in moles, we can do our mole ratio, and we can get the moles and convert back to grams. So that's going to be the whole stoichiometry problem. Look at this. We're going to start out with grams being given to you. You're going to convert to moles using the molar mass. Where do we get a molar mass? From the periodic table. That's where we get our molar mass. So we can convert from grams to moles using the molar mass. Then we're going to use what we learned just now, the mole ratio. we'll have moles of what we're trying to find. But moles isn't good enough because we can't weigh out a mole. So we're going to use the molar mass of that chemical to convert back to grams of what we're trying to find. So these are often referred to as grams to moles to grams problems. They're 3 steps. They're always 3 steps. And you usually start with grams and go to moles and go to moles and goes to grams. So let's give one of these a try. Here's our new balanced reaction. We have 3 FeOs plus 2 aluminums, making 3 irons, Fe's, plus Al2O3 solid. Number 1, calculate the mass of iron 2 oxide, there's a chemical, needed to react completely with 5.55 grams of aluminum, there's a second chemical. 2 chemicals in a balanced reaction means it's stoichiometry, means there's a mole ratio in there. But what we're given now is more realistic because it's what we weighed out, and it's the grams of aluminum. So we're starting with grams of aluminum. All right, I'm going to switch to a new screen. Here we go. We're starting with grams of aluminum, and we're trying to find iron 2 oxide. All right, 5.55 grams of aluminum. It's a stoichiometry problem. We need a mole ratio, so we need to get to moles. We get to moles using the periodic table's molar mass. What's the molar mass of aluminum? 26.98 grams per mole. Is the grams on top or bottom? It's going to be on the bottom because we need it to cancel out. 1 mole of aluminum contains 26.98 grams of aluminum. Grams of aluminum cancels out top to bottom. We got our moles of aluminum now. Now we can do our new mole ratio that we just learned today. Because moles of aluminum is on top, what's on the bottom of our mole ratio? Moles of aluminum. How many aluminums are in the balanced reaction? 2. There's 2 moles of aluminum in the balanced reaction. What chemical were we finding again? Oh, the iron 2 oxide, iron 3 oxide. Iron 2 oxide. Which chemical is that? Well, it's got to have iron and oxygen in it, so it's got to be the FeO. How many moles of FeO are in that balanced reaction? 3. So 3 FeOs is on top of our mole ratio. There it is. 3 moles of FeO per 2 moles of aluminum. Moles of aluminum cancel out top to bottom. All right, we used our mole ratio because it's stoichiometry. Now, grams of aluminum cancel out, moles of aluminum cancel out. We're left with moles of FeO, iron 2 oxide. Did the question ask for moles of iron 2 oxide? No, it asked for grams. How do we go from moles to grams? Yes, we use the molar mass in our periodic table. So we got to add up an Fe and an O. 1 of each. Okay, Fe is 55.85 grams plus an O is 16.00. We get 71.85 grams of FeO in that 1 mole. Remember, molar mass is always for 1 mole. 1 mole. You add up 1 of them in the table. Add up 1 of them. So we needed moles of FeO on the bottom, so it'll cancel out. So the grams is on top. Look at what we got now. Grams cancels of aluminum. Moles of aluminum cancel. Moles of FeO cancel. We're left with grams of FeO. We're ready to put this into our calculator. Let's go. 5.55 times 1 divided by 26.98 times 3 divided by 2 times 71.85 divided by 1 equals. Big long number. How many sig figs? 3, right? Because that's the least. 5.55 is 3 sig figs. 26.98 is 4. 71.85 is 4. We go with the least, 3. Answer, 22.2 grams FeO. That's our first full-blown stoichiometry problem. Grams to moles to moles to grams. 3-step problem. All right, so soak that in for a little bit if you need to. Go back and rewatch that one again. I'm going to go back to the second question. Calculate the mass of aluminum oxide. That's a chemical. Produced when 10.25 grams of aluminum. That's a chemical. 2 chemicals. Reacts completely. We got 2 chemicals in a balanced reaction. We're trying to find grams of aluminum oxide. Which chemical is aluminum oxide? Well, it has to be the one with aluminum and oxygen. So Al2O3 right there. So we're finding grams of Al2O3. It's what we're going to find, but we're starting with 10.25 grams of aluminum. Here we go, number 2. 10.25 grams of aluminum. It's a stoichiometry problem, which means we need a mole ratio. To do a mole ratio, we have to be in moles. We're not in moles, we're in grams. We're at 10.25 grams. How do we go from grams to moles? Molar mass from the periodic table. What's the molar mass of aluminum? 26.98 grams. What's on top, what's on bottom? Well, we need grams of aluminum on the bottom to cancel out. So it's going to be 1 mole of aluminum over 26.98 grams of aluminum. We got our moles. We're ready for the mole ratio. What moles has to be on the bottom? You're right if you said moles of aluminum, because we need moles of aluminum to cancel out. How many aluminums are in the balanced reaction? 2 of them. Okay, so 2 moles of aluminum's on the bottom. What chemical were we finding in this question? Oh yeah, aluminum oxide. How many Al2O3s are there? Just 1. So our mole ratio is 1 mole of aluminum oxide over 2 moles of aluminum. Moles of aluminum cancels out. Now we have moles of aluminum oxide. Did the question ask for moles of aluminum oxide? No, it asked it for grams. How do we go from moles to grams? Molar mass. So we've got to add up 2 aluminums and 3 O's. Do that real quick. Hit pause. Okay, did you add up your 2 aluminums and 3 oxygens? Okay, that's 1 mole. Hopefully you got 101.96 grams per 1 mole. Moles of aluminum oxide cancel out. We have our grams. We're ready for our calculator. 10.25 times 1 divided by 26.98 times 1 divided by 2 times 101.96 divided by 1 equals, big long number. How many sig figs this time? 10.25 has 4, 26.98 has 4, 101.96 has 5. We go with the least, 4. 19.37 grams aluminum oxide is our answer. We have done 2 complete stoichiometry problems. Okay, good job.